Hey, good evening, everyone. Welcome to O-level physics lesson on this new topic of static electricity. Okay, my name is Mr. Chu. Today is the last day of February. Okay, Tuesday, 28th of February, 7:30 p.m. Okay, first of all, let me just share with you the mind map of the topics that you need to learn, okay, in O-level physics. So we have done with the blue topics, the green topics, the yellow topics, and then the last few weeks we've been covering the red topics. Okay, so now we're going to start with electricity and magnetism. Okay, why are these two topics together? Okay, why is electricity and magnetism together? Okay, they are not separate things. Okay, before today or before this year, our idea of electricity and magnet is very separate, right? They are so different. Okay, one is electricity, the other one is magnet. They are so different. Okay, but the fact is they are both related to each other. Okay, electricity and magnetism are related. They are not separate topics. They are not separate issue. For example, I can talk about light. Light is totally different compared to, let's say, kinematics. Okay, they are very different. Or I can talk about thermal physics, very different from wave. Okay, but for electricity and magnetism, they are buddies. Okay, they are like siblings. You can't pull them apart. They are related to each other. If you have electricity, you have magnetism. If you have magnetism, you have electricity. Okay, they are related. And this relationship will be taught in detail in the last two topics, okay, which is electromagnetism as well as electromagnetic induction. Okay, up to here, any question for me? You understand what I'm saying so far? I'm just trying to introduce this whole purple thing. Okay, so the first thing I want you to get away from today is that electricity and magnetism are related. They are not separate entity. Okay, they will affect each other. Okay, when you have electricity and magnetism together, they will have some effect together. Is that clear? Okay, it's not like if I were to put energy, okay, together, sorry, if I were to put moment together with thermal, it's very hard to put them together. Am I right? They are separate things. Okay, but for electricity and magnetism, they are related. Okay, so I talked about their relationship in the last two topics. This last two topics will actually show us how these two are related to each other. So before we learn the last two topics, there's a lot of practical application today that you enjoy due to the relationship between these two. Okay, so in electromagnetism, you will learn that, okay? You will learn that with electricity and magnet, it can make something move. Okay, so that's where you will learn how you put them together to create a motor. You know, our fan, the fan that turn, right? Okay, so you need them to be related so that you can have things like fan. Okay, if they are not related today, we'll be all living in a cave. No fan, no aircon. Okay, got no car. There's no motor at all. Okay, so this topic is very important. Okay, then the last topic is about generating electricity. Okay, so you can have some motion together with some magnet. It can actually produce electricity. Okay, that is where the things like your generator appear. Okay, how do we have electricity at home? The light lah, you know, your handphone got power, right? How do we actually generate the electricity? Okay, you will learn that in the last topic. Okay, are you getting a bit excited? Okay, so this last two topic is very practical. Is the most abstract among these purple topic. Okay, then before that, we'll talk about magnetism by itself. And then before magnetism, we'll talk about electricity itself. Okay, so the first four topic here is all about electricity. The first one is about charges. Okay, about charges. Static means charges that don't move. Then after that, then we talk about charges that move. Okay, when charges move, you will produce current. Okay, is that clear? Okay, so this is the flow of the whole purple overview. Okay, did I give you a good overview? If you all like my overview, give me a thumbs up. Okay, if you don't like my overview, you know already, right? Then give me a thumbs down. Okay, let me know did my overview make you understand this topic better? Okay, give me some reaction, please. Wenxian, are you okay? Hey, y'all like make me beg y'all for thumbs up like that. I'm very sad. Okay, so let me continue with the syllabus of the first topic. Okay, as you can see over here, why is this section together? Okay, so for a long time, like I mentioned earlier on, electricity and magnetism are seen as independent of each other. It's an independent phenomenon. Okay, you see lightning, you see magnet, you thought that humans thought that they are all separate. Okay, then in 1802, before Singapore was discovered, this guy, Hans Christian Ørsted, discovered that a current can produce a magnetism. Okay, so that is the first time where humans discover that electricity can produce magnetism. Okay, because of this magnetism, therefore the compass needle will react lah. Is that clear? Okay, so even though it was discovered in 1802, people never really care about him until 18 years later. Okay, and it takes so the exact relationship between the electric current and the magnetic field, okay, is actually continued by this scientist called Ampere. Okay, now you know why the Ampere come from, because to actually honor this guy called Ampere. Yeah. Okay, however, okay, the greatest discovery in electromagnetism is actually by this guy called Faraday as well as Maxwell. Okay, so Faraday is a unit. Okay, so Ampere is the unit for current. Okay, Ørsted is a unit for what? I forgot already. Okay, Faraday is a unit for magnetism. Okay, you need not know this for O level. Okay, what you need to know is Ampere is a unit for current. And then this guy Maxwell, okay, the Maxwell law you'll be learned in this section. Okay, so we'll start with this first topic called static electricity, okay, where the electrical charges are not moving. Okay, we're going to talk about electrical charges are not moving. Then we're going to talk about moving charges. Okay, when the charges are moving, we call it current. Then we will build on to the voltage and the rest of the item here. Okay, so I'll not go through this. I mentioned that just now. So any question for me so far? So far is my introduction useful by just talking like that? Okay, so let me continue. Okay, so this whole topic, we need to know the 4 subtopic, the laws of electrostatics. Okay, the principle of electrostatics. Okay, the principle of electrostatics, the electric field, okay, and as well as the application of electrostatics. Okay, so let's begin. Okay, so static electricity, have your school taught you all, is the study of electric charges. Okay, it's a study of electric charges that make up electricity. Is that clear? So we are actually studying the electric charges. Okay, we are actually studying the electric charges. Keyword here is electric charges. Understand so far? Okay, and there are two types of electrical charges. One is the positive and one is the negative. Clear so far? Okay, and then the unit for this is Coulomb. Okay, Coulomb is another scientist. Okay, that actually yeah, is another famous scientist. What did he do? I forgot already. I did not remember. I remember what I remember is that as a student like you, I hate scientists. Okay, why that? Because of their discovery, I must study more. And number two, I don't remember what they do. How many scientists do you remember? But actually, as you grow older, you start to appreciate how these scientists actually produce things that actually change our life. Okay, so they are important people. Okay, at your age, you may find that what's the point of studying them? They are already gone. Okay, but as you grow older, I would say that yeah, it's actually quite interesting to appreciate what they have done. Okay, okay, what they have done that actually contribute to what we are enjoying today. Okay, so please don't brush them aside like I did when I was a student. Yeah, because by the time the brain don't have so much hard disk, so don't even bother to even know what they are. Okay, so first of all, you need to know that there are positive charges and negative charges. Okay, if you have learned in chemistry, negative charges is the same as electrons. Clear? Okay, of course, in chemistry, negative charges can be also anion. Have you learned this before? Anion. It's yeah, it's just negative charges. And then positive, same thing, there are a few patterns. Okay, it can be cation, you learn that in chemistry, or it can also be protons. Okay, these are all positive charges. Okay, up to here, any question? Up to here, did I make myself very clear up to here? Okay, can you give me some reply? Chat, give me some interaction in the chat. Okay, am I so far clear in my introduction? Yes? No? Maybe? Okay, so the first statement is there are two types of charges. There are positive charges, example, protons and cations. Okay, cations, you learn that in chemistry. Okay, there are also negative charges like electrons. Okay, in the chemistry, you also learn anion or negative ion. Okay, so these are all negative charges. And there's the unit to measure them, you measure them in Coulomb. Okay, I want you to notice when we spell the unit, this is small. Okay, Coulomb, the short form is capital C. Is that clear? Same thing, when we spell ampere, A-M-P-E-R-E, we actually spell it with a small a for the unit, the ampere unit. But when we actually write down the symbol, it's a capital A. Okay, and that is the same for a lot of things. Okay, all the scientists you can remember, okay, like Pascal, you learned that last week. I actually mentioned Pascal. Okay, these are famous scientists, or there's another scientist called Watt. Okay, so when you spell out their unit, it's all small letter. Okay, it starts off with a small letter. But when you spell their name, okay, please respect their name. It is a capital A, capital P here, capital W, and capital C. Sorry, capital C for Coulomb. Okay, so when you spell out their name is capital, but when we spell out the unit, the first letter is all small. But their symbol are usually all capital. Can you see from here? They're all capital. Okay, so that is one thing I want you all to remember. Okay, so let's continue the laws of electrostatics. Okay, so what is the laws of electrostatics? Okay, the laws of electrostatics is that just like what you learned this before. Okay, you learn that okay, in primary school, you learn about magnet, right? Unlike pole attracts. Okay, and then like poles repel. You all learned that in your primary school before? Okay, same thing when you go into electric charges, it's the same idea. So unlike charges will attract. Anything that they are opposite, just like boy and girl, they attract. Then two boys together, they repel. Okay, so like charges repel. So just remember, it's the same for electricity, it's the same for magnetism. The idea is the same. You just need to change the charges with pole. Okay, so for electricity is unlike charges attract. For magnetism is unlike poles attract. Up to here, can you all remember this concept? So you don't need to remember 4 or 5 different concepts, just remember one. Is that okay? Can okay, so I'm going to talk about the next thing called the field, the third one. Okay, electric field. But before we talk about electric field, let me explain a few things. There's a few things that you have studied before. There's 3 fields that you're going to learn in physics. So what are the 3 fields? Okay, you have learned the first field before, gravitational field. Have you learned this before? Have you seen this word before, gravitational field? Okay, so it's the same thing, just that it is gravitational. And then moving forward later, when we go to the topic of the topic of magnetism, you also will learn this thing called the magnetic field. Is that clear? Okay, so why did I write this out is because I want you to see a pattern. So instead of remembering the 3 fields, you just need to remember 1 field and then change the wording. Is that clear? Okay, so you can see over here, the electric field of a charge, okay, of a charge. Okay, sorry. I draw the wrong side. Let me go up here. Aha, okay, down here. Okay, here should be where I'm talking about. Okay, so an electric field is a region where an electric charge experiences a force. Is that clear? Okay, so now I want you to write the same thing. Okay, gravitational field. Okay, gravitational field is also a region in which something experiences a force. Okay, understand so far? Can you see a pattern that I'm trying to share with you? Okay, same thing for magnetic field. It's also a region in which something experiences a force. Okay, so the pattern is the same. Okay, what is different are some words. So what are the different words? Let me share with you. The different words will be things like the gravitational field is different, electric field, and magnetic field. So these 3 words are different. Okay, and then plus these 3 words that you're going to fill in here, they are also different. Can you all remember this? Okay, so far? Okay, so what is the word we put inside here? Okay, let me write down for you. Okay, so for an electric field, it's a region where an electric charge experiences a force. Is that clear? So the electric charge will have a force. Okay, how about for gravitational field? It's a region in which what thing experiences a force. Okay, the keyword here is which a mass. Okay, gravitational field and mass are related. Okay, so the word here is a mass experiences a force. Okay, and this force is called weight. Do you remember that? When a mass experiences a gravitational force, it's called weight. Then for magnetic field, it's also a region in which a magnetic material experiences a force. Up to here, any question? Can you see the pattern here? The only thing that changes is the word gravitational, electric, and magnetic. So gravitational is where a mass experiences a force. Electric will be electric charge experience a force. And then the magnetic field is where the magnetic material experience a force. Okay, do you understand what I'm trying to share here? So there are three different definition that you need to remember. But instead of remembering all three, I'm trying to share with you the link. Then you all can actually just remember one and then remember the different words here. Okay, that's what I'm trying to achieve here. Any question for me? Then in my school, in my secondary school where I study, we have the fourth field, which is the name of my school. You want to know which school I studied in or not, in my secondary school? Which school has the word field inside one? You want to make a guess? So very funny. When we learned physics last time, teacher tell us there are 4 fields that you need to remember. So guess which school in Singapore has the word field inside? Come, make a guess. Or you want to give up? Nobody know Yeah, type up in the chat. So people in the video will not know. Okay, you don't know which school in Singapore got the word field inside. Okay, this is my secondary school that I studied in. Do you all find it funny? Okay, so far there's a lot of things I've written here. Can I erase everything or you all need to be okay? Let me just leave it there. Okay, next one. Let's talk about the next one. Okay, you need to also draw an electric field of an isolated point charge. And recall that the direction of the field line gives the direction of the force acting on the positive test charge. Okay, so we are going to talk about this one. Okay, we're going to talk about this one. We're going to talk about electric field on an isolated point charge. Okay, on an isolated point charge. Let me show you how the field will look like on an isolated point charge. Okay, meaning that just one charge. Okay, so let me show it to you. Okay, so over here, can you see? A charge can have a positive or a negative. A charge can have positive or negative. It can be either positive or negative. Okay, so there's 2 types of charges, or either a positive or negative. Okay, so far. Now I'm going to just draw a line in between. So how many want to draw negative one? Wenxuan, you want to try doing the positive one? Okay, how many has took out the initiative to do the negative? So Wenxuan, can you do the positive one? Thank you. Okay, very good. Okay, so for positive charges, you see arrow going out. Then for negative charge, you see arrow going in. What does this mean? What does this arrow means? Okay, so can you tell me this arrow means what? Anybody can tell me what does this arrow actually mean? Anyone? Anyone? Okay, so I want you all to just imagine this is a positive, this dot here that I'm drawing is a positive charge. Okay, just imagine it's a positive charge, even though it doesn't look like a positive charge. Okay, do you remember if I got two positive charge, one in the center here, okay, and then one dot here. Can you see these two? They are light charges, correct? They are light charges, they should repel. So this thing itself, let's say this center positive charge cannot move. It's stuck there. Okay, so the other one will actually repel, it will actually move away. Clear? So this line actually means when you put a positive charge at that point, you'll move along the line. Okay, you'll move along the line in this direction. Are you all clear about this? Okay, did I make it very simple to understand? Because I remember in the past when I was a student, I don't understand what it is. Just memorize. When you just memorize, it doesn't make sense. Okay, so can you see if this blue color is a positive charge? Okay, positive charge, it should actually repel. So how they repel? If it's when this thing is placed in this field, okay, all this line, this arrow is the field. When this positive charge is placed in the field, this positive charge will experience a force. They'll allow it to move in the direction of the arrow along the line. Is that clear? If I put this positive charge here, it will just follow the line in the arrow. Understand now? Okay, then for negative charge. Okay, same thing. This blue color is still a positive charge. Okay, what you're talking about is positive charge. So this arrow actually is just an indication of how a positive charge will move. So can you imagine this positive charge and the center is a negative charge, and they are unlike charges, so they should attract. Is that correct? They should attract. Clear so far? Okay, so they should attract. It should go towards each other. So what this line actually mean? This line arrow mean if you actually put the positive charge on the line, you move in the direction of the arrow. Does it make sense? Okay, if I put this charge on the line, you'll move along the line in the direction of the arrow. And that is talking about positive. So the arrow is talking about positive charges. How it will move when you place a positive charge there. Okay, what if I change this to a negative charge? Okay, I change it to a negative charge. What happened? Okay, I have a negative charge. Okay, the red color represents negative. Okay, so because the arrow is telling us how a positive charge will move, and if I put a negative charge here, it should move against the arrow. Does it make sense? It moves against the arrow, it moves towards the plus. Why? Positive and negative are unlike charges, it should actually attract. Does it make sense to you all now? Same thing, I put it here. This is now a negative charge. They are both negative, so like charges repel. Okay, so this negative charge, if I place it down here, you'll move along the line, but because it's negative, you'll go against the arrow. Okay, you'll go against the arrow, you'll move away this way. Understand so far? Any question? Did I make myself very clear about how to draw the electric field line, okay, of an isolated point charge? Okay, so this plus and minus that I draw here are isolated point charge. Okay, is that clear? Okay, static electricity is one of the topic I don't like when I was a student. I don't know, I just find it very boring. How about you? So far, did I make it interesting for you or not? Did I make it easy to understand? Okay, hello, some feedback there. Okay, so we have finished talking about this one. Draw an electric field of an isolated point charge. Is that clear? And then the direction of the field line tells you what is the direction of the force acting on the positive test charge. Okay, so the direction, the arrow of the field line is actually the force direction, the direction of the force pushing the positive test charge. That's what I mentioned just now. Okay, now we're going to draw the next one. Draw an electric field pattern between two isolated point charge. Okay, so I'm going to draw two patterns. So later one of you draw one, quickly choose one, and then the other person will do the other. Okay, why is it still this one again? Let me add a page. Okay, so I can have 2 point charges. Okay, 2 point charges. They could be the same, plus and plus. It could be different. Okay, so now I have two isolated point charge. Okay, this one could be plus plus. It can also be minus minus, but I use plus plus for now. Then this one will be plus and minus. Okay, so let Wenxuan choose first. Wenxuan, you want to do the left side or the right side? Just try. It's okay to be wrong. But it's not okay to continue to be wrong after I teach you. Okay, then how Ming, you do the right side. Wait, how Ming, you draw finish? Why you draw halfway one? It looks so weird. Okay, let me show you how you should draw. Okay. Okay, but anyway, just looking at the pattern here. Okay, I want you to look at the pattern here. Look at the left side. Left side is we call this light charges, right? Okay, just look at the left side here and follow. Okay, you look at the pattern. You look at the lines that he's drawing. Are you drawing more lines in between, or are you trying to put, or are the lines trying to enclose them together so that they actually come together? Okay, looking at just from this diagram. Okay, write down in the chat. Okay, does the line shows that they are trying to separate the two charges, or does the line trying to bring the two charges together? So write down your answer in the chat. Thank you, Hao Ming. How about Wenxuan? Based on what you draw, does it seems like the lines are bringing the two charges together or bring them away? Okay, very good. Okay, let me continue drawing. You should draw further like this. Okay, you should draw some more. Okay, so when you draw something like this, you can see that there are a lot of lines in between them. there are a lot of lines in between them, okay, trying to push them away from each other. Okay, so these two charges should actually move away. Okay, when it's plus, the arrow comes out. If it's two are minus, the arrows go inside. Is that clear? Okay, so it's always from plus go to minus. Okay, just remember, plus go to minus. Okay, so let me just continue talking again about the the charges. Okay, the charges. Let me give an example. So this is your positive charge. If I place them in the field, like here, okay, this positive charge, it will actually follow this arrow, this line, this drawing, then in the direction of the arrow. Okay, same thing, if I put it here, it will actually move in this path, in the direction of the arrow. Okay, that is how a positive charge will experience a force, okay, inside this field. Okay, this whole area is a field. So I place this positive charge anywhere in the field, it will by right follow the path of the line in the direction of the arrow. Is that clear? If it's a negative charge, you also move along the path of the line, but in the opposite direction of the arrow, like this. If it's negative, you move this way. Understand? Then if I got one more positive here, right in the middle, you will not move lah, because down here got no like arrow. Clear so far? If I place a positive charge right in the middle, then you will not move long. Make sense? These two will move away long, move to the right, move to the left. Clear so far? Okay, that is for the light charges. Okay, next one will be unlike charges. Okay, the way you draw it's not symmetrical at all. Can you draw it a bit more symmetrical? Okay, draw it more symmetrical. Okay, these two lines wrong. It shouldn't be like this. Okay. And okay, allow me to redraw. Okay, allow me to redraw. Okay, first of all, very good. The first line you draw from plus to minus, this one is correct. Is that clear? This is correct. Okay, then if you will continue, you'll be going in, this will be coming out. Okay, so this one whole line, any question? These two lines that you see here, these two lines you see here is going out of the plus. Then the two line is going into the minus. So this straight line, any question? No question, Then, in between, you should draw something like this. Can you see? Can you see the difference between the way you draw and the way I draw? Okay, same thing. I will do the arrow. Clear so far? Now, then the rest of the area here, how do I draw that it makes sense? Okay? How do I draw that it makes sense? It should be like this. It should be curved this way. Can you see? It actually fit this way. Okay, same thing. I will draw it this way. It will fit in this way. So now, Hao Ming, do you see the way you draw versus the way I draw? Are you able to see the difference? Do you know the error that between your one and my one? Okay, this angle should be coming this way. Follow the same angle like this. Okay, this one should be in this manner. Should be the same type angle. Because for you, you draw this way. You draw this way. Remember just now? You draw it like this. Let me use a red color pen to show you. Okay, you actually draw it this way. Okay, wrong. You should follow the same line. Clear so far? Okay, so likewise, if I were to put a positive charge anywhere in the field, so this whole area is the field. Okay, where did my charge go? Oh, here. Hold on. Okay, so if I place this positive charge anywhere here, I said I put it here. It will follow the path of the line in the direction of the arrow. Can you see it's moving away from the plus Because plus and plus repel. Then it move towards the negative because plus and negative will attract. Is that clear? Then if you look at the whole drawing here, can you look at whole drawing here? Does it look like it's trying to bring the two together like a matchmaker? Whereas you look at the drawing on the left, they are trying to, having a gap between them. There's a gap between them, so they are trying to move them away. But for this diagram here, the whole thing, can you see? They are trying to push them together. Can you see from the drawing? Does it make sense to you? The drawing is trying to push them together. Make sense? Okay, then the other thing I will share with you is this. I'm going to use another color. Maybe I use blue. Can you see that the distance here versus the distance here? Which one has a greater distance? Can you type out in the chat? A or B? Which one has a greater distance? Let me know in the chat. A or B? Okay, Wenxuan say A. How about Hao Ming? Okay, very good. How far the field lines are from each other also have a meaning. When the field lines are very close, okay, when they are very close like this, okay, it actually is when it's very close, it actually means that the electric field strength is stronger. Okay, when this arrow is very far like this, okay, very far like this, it means that it is actually weaker. So can you remember, if they are close together, they are stronger. When the lines are close together, they are stronger. When the lines are further apart, they are weaker. Clear so far? Now, are all of you able to draw these two things? Yes or no? Can all of you draw these two things? Okay, so I'm going to revise magnetic charges. Okay, I can erase this here. I can erase this and replace with something else. Okay, can I replace them with something like this? Then you see whether it makes sense. Can I put two north pole here? Can I put two north pole here? Just now it's two positive charges. So now I just replace two north pole here. The diagram is all the same. Make sense? How about I do this? Can I do like that? This is the north pole. Okay, this one we cannot do that. Okay, this one I must draw something else. Okay. Can I draw something like this? This is my north pole and this is my south pole. Can I do something like this? So can you see the same thing that you learned today? You're going to draw the same pattern when you're going to do the magnetic field. Is that clear? So can you remember this today? Then when you go to the magnetic field topic, you're going to draw exactly the same thing. And the same theory goes. Okay, if your north pole is here, okay, if your north pole is here, or your compass is here, you actually can plot your compass in this direction. Okay, what do I mean? What do I mean by this? If I have a compass, let me show you. If I have a compass down here, okay, my compass will point this direction. Okay, it will point this direction. You know what I'm trying to say? If I put a compass along this line, it will follow the path and then in this direction. Okay, so that is what will happen okay, in a magnetic field. So you can see what I'm trying to do here. I want you all to link everything together. They all follow the same pattern. Okay, once you know that there's a pattern, you need to remember everything. Okay, you just need to know the link, they'll be fine. Okay, so if you're okay with this electric field line, okay, give me a yes reaction. Okay, thank you. Well, how many? What is that? Give me a creature reaction just now. Okay, let's continue. Okay, so where have we done? Okay, so we have done the isolated point charge, correct? Then we have done electric field between two isolated point charge. Okay, then we need to show understanding that electrostatic charging by rubbing involve a transfer of electrons. What does this mean? If you use a cloth to rub insulator rod, you just rub and rub and rub. Okay, rub and rub. Okay, if there is a transfer of electrons, electrons here can transfer to the rod. So the rod become more negative charge, and then your this cloth can be more positive charge. Okay, this is one of the things as a student I hate most. I cannot always remember which one will cause a positive or negative. Okay, but this is just an example. Okay, it's just an example. Okay, so for the rest of the item here, it's very hard for me to explain based on this pointer. So let me go through certain notes. But up to here, any question? So when there is a electrostatic rubbing, okay, when you have electrostatic charging or rubbing, okay, rubbing two insulator, it doesn't work for conductor because conductor, the electrons are free to move. Okay, so whatever you do, the electron can still move. Okay, but for insulator, the electron stays with the nucleus or the atom. So the electrons are not free to move. So when you actually do give some friction or some movement or some rubbing, some of the electrons will be displaced and then will be moved to the other material. Okay, this is what you call by electrostatic charging. Okay, you're using friction or rubbing to cause the electrons to jump from one material, one insulated material to the other insulated material. Is that clear? Okay, so in this case, I'm talking about insulated material. Okay, not conductor. Okay, now let me clear everything here. So let me see some notes. Whether is there any example? Okay, let's look at this. Why the notes is like halfway one? Okay, so can you see here? Okay, first of all, I've mentioned about light charges repel and light charges attract. So you all know this. Okay, the unit of charges is Coulomb. Okay, Coulomb. So charge. Okay, charge. What's the symbol for charge? The short form for charge is Q. Okay, the short form for charge is Q. So the unit for Q is C. Are you all starting to get confused? So for example, I say charge is equal to 1 Coulomb. Okay, 1 Coulomb. Okay, so if I were to write it in symbol form, I write down Q is equal to 1C. Is that clear? The charge is equal to 1 Coulomb. Okay, when I spell out, it should be small c. When I use a unit symbol, it should be a capital C. So this Q is a replacement for charge. And I know you have used this Q before. Which other quantity you use a big capital Q? Okay, when do you use the capital Q before? Have you all learned this before? Energy. You remember this Q? This Q is actually represent energy. Okay, but this Q is represent charge. Clear so far? Okay, then insulators can be also charged by friction by the transfer of electrons. Okay, so I explained earlier. In a insulator, okay, the electron cannot move freely. Okay, it cannot move freely. Okay, so when an insulator is neutral, look at this first example. The glass rod has the same number of positive charge, which is the proton, and the same number of electron, the negative charge. Same thing for the silk. They are the same number of plus and the same number of minus. So both of them are neutral. Okay, both of them are neutral. Okay, the keyword here is they are both neutral. Okay, because they have the same number of positive charge and negative charge. Now, when you rub them together, you rub, use the silk to rub the glass rod. Some of the electrons from the glass rod will jump to the silk. So because the glass rod has less electron, so the glass rod now become positively charged. Is that clear? And now because the silk takes some electron from the glass rod, so the silk has more negative electrons. So now the silk is negatively charged. Okay, so these two are actually charged. So for example, this glass rod, when it's positively charged, there are less electrons, they are positively charged. You bring this glass rod to near your hair may be attracted to the glass rod and therefore it starts to stand. Okay, that is one phenomenon of static electricity. Because it's a positive charge or negative charge, you bring it to another item, like small piece of paper, you are able to attract, okay, due to the charge. Understand so far? Okay, any question for me? Okay, then the other thing is this, electrical insulator do not conduct electricity. Okay, because there are negative charges, it doesn't move freely. Unlike a conductor, an electrical conductor is able to conduct electricity because the negative charge can move freely within the material. Okay, that is why insulator do not conduct electricity, whereas an electrical conductor like metal, they can conduct electricity because their electrons can move freely. Okay, so any question so far? Okay, no question, so let me continue. Okay, the principle of electrostatic. Okay, this is the thing that will take a bit of time to explain. Okay, so we have talked about single charges, the field. Okay, this one I'll pass you all the notes, you're going to read yourself. Okay, so the part that is hard to understand will be this one. Okay, so this one. Okay, so let's look at how do we charge a single metal conductor? Okay, how do we charge a single metal conductor? Just follow me. Once you follow me the idea, it should be hard. Okay, the metal conductor here is what? Okay, let me just scroll up a bit more. Okay, let me expand. Okay, so the metal conductor that you see here, what does it mean? Okay, so you can see here, single metal conductor actually refers to this thing. Is that clear? So this thing at first is neutral. At first is neutral. Can? Then I bring a positively, can you see here? I bring a positively charged rod. This one, all positive, near this metal. Okay, when it's near. So when it's near, but don't touch, don't touch. It must be near. Okay, why don't touch? Because we don't want the electron to move around. Okay, we don't want the electron to move around. Okay, so we bring it near. So because it is positively charged, it will attract the electrons on the near side. Okay, and then on the other side, it will be positively charged. Okay, this is what happened. Clear so far? When you bring a positively charged rod near this metal conductor without touching, okay, you bring near, the side nearer to the rod will be negative, okay, because unlike charges attract. Then the other side is positive. Understand so far? Then step 2, what you do is you bring a ground. You ground the side that is opposite the other end. Okay, so when you ground it here, when you put a hand here, this ground either provide unlimited electrons or it actually can absorb unlimited electron. Okay, now, because this is positive, when you ground it, okay, when you ground or earth this side, okay, when you earth it, this ground will actually, or this earth will actually either provide or take away any excess electron. Okay, because down here is all positive charge, because the electron all flow to the left side, am I right? So on the right side, there is lack of electron. Okay, so the ground or the earth will provide the electron to this side. Okay, so the right side here will all become neutral. Okay, like this. Okay, I'm talking about the right side only. We don't talk about left side. We talk about right side. You become neutral because the earth or the ground provide the electron to neutralize the positive charge. Okay, everything being equal, the earth would want to neutralize things. Understand so far? Why is on the left side is still negative? Okay, why the left side here is still negative? Why? Because this glass rod is there to still attract the negative side. You understand what I mean? This is like your, the attractor. Okay, so this is the boy, attractive boy. So the 4 attractive girls, okay, are still attracted to the attractive boys. So they are still here. Whereas down here on the right side, no, the girls that have left them. That's why the girls go to left side. The positive, the boys left. So the boys are single. Okay, so this ground provide the girls to make them all happily neutral again. All happily become a couple again. So on the right side, okay, they are all matched. The positive and negative are all matched. But on the left side, these 4 girls are still attracted to these 4 boys. You all understand what I mean? Then these 4 boys move away. These 4 boys left the metal rod. And all these while they don't touch, so they cannot jump. When they touch, then they can actually jump ship. Okay, but they don't touch, they can only view from near. Okay, so then these 4 boys move away. What happened to these 4 extra girls? No more boys ready, right? To get them excited. These 4 girls will now spread themselves evenly among the metal. So now this whole metal here are negatively charged with 4 excess girls. Okay, without any couple. Very sad. Okay, they got scammed. They actually come to left side, hopefully to match with these 4 handsome boys. Okay, then after that, you introduce your hand to actually make the boys here get matched. So these 4 boys will get matched. Okay, these 4 boys will be matched. No more excess boys here. Okay, so on the right side, they are all happily matched. You take away a hand, they're all happily matched. On the left side, these 4 girls are still attracted to these 4 boys. But the 4 boys decide to go away. Then the 4 girls have no reason to stay on the left side. They'll spread themselves out. So the whole thing here now is become negatively charged. So I use this boy and girl thing to explain. Does it help you understand? Does it help you understand better? Yes or no? Hello. Okay only ah. That's sad. Okay only. How does your school teacher explain to you all? Or you all prefer, okay, you all prefer whose explanation? Your school teacher or my explanation? Okay, give me some feedback in the chat. Hello? Or both equally good? Which explanation you prefer? How many haven't learned yet? How about for Wenxuan, you just started write this topic? Have your teacher talked about this? So you like, wow, you good ah, don't want to 得罪人. Okay, so I'm talking about charging a single metal conductor by induction. Induction means no touching. Okay, you try to be near, but don't touch. It's just like if you're a boy and the girl you like is so near you, okay, then your whole body feel funny, right? That's called induction. Okay, they never touch you, also you feel funny. Okay, that is called induction. Okay, same thing. For a girl, if you stand very close to a guy that you like, you also feel funny, right? That's called induction. They don't need to touch you, also feel, you also got reaction. Okay, next one. This is charging a charge insulator. Okay, what is this about? Okay, so when an insulator, this insulator could be balloon, okay, balloon. It could be anything that's not a conductor, right? And this insulator is charged. So how do we discharge them? Okay, how do we discharge them? Two ways. Number one, you can use heat. Okay, so one of the insulator we talk about is the glass rod. So can you see down here the glass rod? This glass rod is a charged insulator. Okay, positive charge rod. You bring this glass rod, okay, this is the glass rod talking about, it's positively charged. You bring it near a flame. Okay, you bring it near a flame, fire, okay, fire. Okay, when you bring it near a flame, the heat will ionize the air around it. And then this ion, this negative ion around the glass rod will actually, this negative is the girl, remember? Then we are all the boys stuck here. We're very poor thing. All the boys inside the positive glass rod. So when you are in a heating environment, okay, this fire produces boys and girls. Can you see? They produce boys and girls. And some of these girls here will neutralize. Some of these girls here will actually go to the glass rod and neutralize. And therefore, the glass will now be discharged. Are you clear about this? You understand this? Okay, next. Hey, how Ming, you don't can tell right this one. Why you watching my video? I ask you to put video, you don't want, you ask then you watch my video. Okay, then in a humid condition, when there's a lot of water molecules around, okay, for example, so now we are talking the same example, but we're talking about a negatively charged balloon. Okay, a negatively charged balloon. Okay, so in the surrounding is very humid. Okay, the water molecules are actually like an electrical conductor. Okay, so it will produce extra charges. It could be plus, it could be minus. Same thing, we have all the girls stuck in the balloon. Extra girls. The rest of the girls in the balloon are already matched with a boy. So we still got all these extra girls that is unmatched. Okay, very lonely. But in the environment, there's actually a lot of water. The environment is humid, there's a lot of water, and water molecules can actually become charges easily. Okay, so can become charges easily. So the excess positive charge, the boys, will be attracted to the girls in the balloon, and therefore the balloon they can become discharged. Is that clear? Okay, so are you clear? So now if I keep on using the boys and girls. Don't get me wrong. I just trying to make you understand better. Don't go and complain that this teacher sexist. Okay, now this one, the more complicated one. Okay, the more complicated one. Earlier on, we are trying to discharge a charged insulator. Okay, not a conductor. So now we are trying to discharge a charged conductor. Okay, we are going to discharge a charged conductor. So this conductor is charged. Okay, there's a lot of girls inside. And excess girls. Clear so far? There's a lot of extra, there's 4 extra girls inside. And this girl can freely move around because they are negatively charged. Okay, so for a charged conductor, to discharge is very simple. Okay, remember just now? You need to actually connect any earth to the conductor. The earth will provide unlimited boys and girls to the charge. Is that clear? So in this case, there are 4 excess girls or 4 excess negative charge. When I connect a earth to this sphere, these 4 negative charge or the girls can escape to earth. Then this sphere will become neutral. Understand so far? Same thing, if it's a positively charged, your earth itself can either give a lot of girls or take away a lot of girls. I let girls be like the electron. Okay, I use the word girls equal to electron. Okay, why only girls can move? Because only electron can move. Proton cannot move. So the boys stay there. Okay, the boys stay there. It's the girls, the electron that move. Okay, so on the first part, we got extra girls, extra electron, the electron move away. Then on the second part, positive charge because lack of electron or lack of girls. Okay, they are positive charge because these boys cannot move, right? These 4 boys cannot move. Okay, their girlfriend have disappeared. So they are all single. Or the 4 boys are single. So to make them match, you need to bring the girls in. Okay, so the negative charge is the electron. Okay, so you need to bring the electron in, then they will match and then become happily ever after. Okay, you all understand what I'm trying to say? Okay, so I'm using boys equal to protons. And protons cannot move. Understand? In a conductor, it cannot move. Whereas the girls' electron can move. Okay? So in this case, these girls, they can move around. They cannot find any more boys, so they can run away. When you touch it, they run away. Okay, they find all the boys at the earth. Then in this case, the boys cannot move. They got lack of girls, the lack of electron. Okay, then you actually can move back to the charge, to the sphere. Understand so far? Okay, why your friend now the hair like Einstein like that? What happened to your friend? So what's your friend doing? Okay, why your friend like that? You all know why or not? Okay, do you know what's happening here? Is your friend actually standing on the insulator? Standing on the mat? Chair. Okay, so this one here, that's for example here, is your insulator. Can? So for example, this sphere will give you a lot of positive charge. For example, okay, I don't use positive it's just confusing. I use negative So the sphere produce a lot of negative charge. And when you touch it, this negative charge go to your body. So the hair itself are all negative charge. Understand? And because light charges repel, so the only way for them to repel is for the hair to stand up and then be far away from each other. Understand so far? What's happening here? Okay, is that correct? Is that the way teacher explained to you all? Okay, so they now this ball produce a lot of negative charge, for example. So negative charge can go to your hair. Okay, so the hair itself got extra negative charges. And for them to, because they are light charges, for them to be far away from each other, they need to stand up. So that the distance between them is further. And because the hair is light, you can stand. Okay, if your hair is not light, then of course you will not stand. Make sense? Okay, thank you for a picture. You can use handphone in class one. What school is this? Also got aircon some more. Wow, so good. Why your school got aircon, can use handphone one. Wow, can use iPad some more. Okay, let's continue. How you all find today's explanation? Did I make this topic interesting for you all? You mean what? Go to school must actually put the handphone in the locker. Okay, I explained this earlier to you all. The only thing I did not explain is this one. Can you look at the last one here? Okay, same thing. Plus always go to minus. So in between the plate is they're all parallel. Okay, and the side is slightly bent. Okay, so if I were to put a positive charge, okay, in this case, a positive charge between the plate, you will move in the line in the direction of the arrow. Is that clear, Hao Ming? Why you suddenly give me lightning? You want to kill me, is it? Understand so far? Okay, so can you see here? I also mentioned when the field line are further away, they are weaker. When they are closer, they are stronger. Is that clear? So here, can you see? They are quite far apart, so it's weaker. Okay, here is quite close, so it's stronger. So are you clear about this? Then you can replace the plus and minus with a north and south pole. It's exactly the same. Okay, your plus is like your north pole. Then your minus is like your south pole. Can? Now, what is this about? Okay, so let me just explain this. Electroscope. Okay, electroscope. Okay, so everything here, can you see the brass cap is neutral because all the boys and the girls, okay, are happily matched. So they are all neutral. Understand? Then, if I were to bring a charged glass rod near, okay, because of induction, this is all the boys. What happened? These are the boys on top. Then, all the girls in this thing, there are 4 girls here. Can you see? There are 4 girls. 4 negative. They know that the boys are coming. These are the hot boys. Okay, so they all happen to come on top. Okay, they are attracted to the glass rod on top. Okay, what happened? The bottom only left with the 4 available guys. And because of light charges repel, so this gold leaf actually will this is in down here itself, light charges repel. Okay, so therefore the gold leaf will diverge. Understand now? Okay, because at first it's neutral. Neutral, they will not repel, right? But because of this, suddenly the boy band come over. Then all the girls go up. Okay, they only left the boys below. Okay, so these 4 boys are actually left below. They are all the light charges, they'll repel because they are not gay. So therefore they repel. Understand so far? Okay, so for Wenxian, your classroom normally no on aircon one, only for the experiment on. Okay, let's see the last few pages. Okay, so what are the hazards and application of electrostatic? Okay, this one, can you promise me that you'll read yourself? Okay, I'll not go through. You'll read yourself. Or you'll read through now. If you understand, give me thumbs up. If you don't understand, I'll explain to you. Okay, just read through. First, read through lightning. So before recess, make you all suffer. Make you all smelly. And sweat a lot. Then after recess, then give you all cool down. Okay, so I've highlighted certain keyword for lightning and electrostatic discharge. Okay, so have you seen some truck when you see some metal always touching the floor? Okay, that actually produce more friction, right? But there's a important use for that. It actually ground your truck. It doesn't let your truck, okay, accumulate too much electrostatic charges. Okay, so this metal chain, this metal chain in the vehicle help to make sure that your truck do not accumulate too much charges. So if it's too much charges, you on your lighter, want to smoke, suddenly the whole truck bursts out. Understand so far? Okay, lightning, you all read about it. Okay, let's finish up today's lesson. Okay, read through this. Okay, this is something like a filter. Okay, so for example, you burn a lot of things, there's a lot of ash. The ash, the smoke, okay, the byproduct of burning can be a lot of ashes. So how do you actually minimize the ash from escaping the chimney? Okay, so you can actually charge. Okay, have a two metal plate. They are actually charges that actually positively charged by the side of your chimney. Can you see here? Okay, because it's positively charged, as your ash move up the chimney, it will be attracted to the metal plate. Okay, so because they are attracted to the metal plate, these ashes will most of the ashes will not escape into the air and then pollute the air. Understand so far? Oh yeah, and then before that, you need to have a negatively charged wire here. Okay, so as the ash pass through the wire, this mesh, the ash become, okay, these ashes are neutral. This wire is the negative. Okay, as it pass through the negatively mesh, now all these ashes will become negatively charged. And because this is positive, they unlike charges attract, so the ashes being negative will be attracted to the plate, so they'll be attracted to the plate rather than go up all the way to the air. So it actually reduces the ashes polluting the sky. Understand so far? Okay, if you understand, give me a thumbs up. Thank you, Wenxin. How many you understand? Does it make sense to you? Okay, very good. Now, application of electrostatic. Okay, we just the last part today. So we have this photocopier. Okay, photocopier. How does a photocopier make use of electrostatic to work? Okay, I try to explain this. Okay, I also not very good at this, but let me try to explain this. So in a photocopier, there is a metal drum that is coated with selenium. Okay, selenium is a photoconductor, meaning that you only conduct electricity in the presence of light. Okay, then we talk about that later. Then the drum is charged positively on its entire surface. Okay, so what's happening here is there is this wire, charge wire, and then the drum will turn. So the whole drum will be positively charged. Can you see here? This is all positive. Okay, positive. Okay, and it's charged by this wire. Okay, then you put a piece of paper here. There is the ink, like I. So how are you going to print this? Okay, so this is the original paper you put on the photocopier. Then you shine a very bright light. Okay, bright light on the image. Okay, so the darker area will actually reflect less light. Okay, then the region, the lighter area here, okay, will actually reflect more light. Okay, so far? Okay, so remember I told you about this metal drum is coated with selenium. So it will only conduct electricity in the presence of light. Okay, so the white color part will actually it will actually conduct electricity. So this part will conduct electricity. Can you understand? When it conduct electricity, all the plus will escape, correct or not? Because it actually can conduct electricity. Only the dark color part, this part, doesn't conduct electricity because there's less light reflected. It doesn't conduct electricity, so the plus remain there. The positive charge remains here. Understand now? So this part remain positive charge because it does not conduct electricity. Are you clear about this? Okay, so the part where it conduct electricity, it become discharged. So it become neutral. Only the part where there's no light, it remains positively charged. Then, as it turn one round, the positively charged image will attract the negatively charged toner powder. Okay, you will actually attract the negatively charged toner powder. Then what happened? Okay, so because this is only left positive charge, right? Okay, this is part is only positive charge. The toner is only negative charge. Okay, so positive and negative attract. So the toner is the ink, then the ink will actually go into the positive charge, forming the image. Very cheap, right? Very not easy to understand, right? So understand now? You understand what I'm saying? Okay, if you understand this whole process, give me a yes reaction. You want me to explain one more time? You know it. So fast. So far thumbs up. Okay, so before we go, same thing. One thing I learned today. 2. How much I learned today. Okay, give a rating of 1 to 10. How well Mr. Chu teach today? Okay, that's all. 3 questions. Once I call your name, you may leave the class and I'll see you next week with practice. Position 1 to 10, what give me 97? Okay, Wenxuan, you may go. Wenxuan, you have learned this topic and then today you learn another 9. So your teacher only teach you all 1 ah? Hello, 1 to 10 why you give me 88 lah, 97 lah? And you all give me something more between 1 to 10. Okay, thank you so much. Have a good day. And both of you, you may go. Good night, goodbye. See you next week.